Okay, so on Monday, we talked about different congruence theorems like SSS, which was side, side, side. There was ASA, angle, side, angle. We had AAS. And finally, the last one was SAS. So remember, we needed to know three different congruent corresponding angles or sides for all three of these rules. We used three of them. Well, today we're gonna learn a new rule called the hypotenuse leg congruence theorem. And as you might guess, we're gonna need to know a hypotenuse and a leg. And again, if you recall that right triangles are the only kind of triangle with a hypotenuse. So for these, we're going to need a right triangle. We need to have a right triangle in order to use a hypotenuse leg congruence theorem, because only right triangles have a hypotenuse. So our main rule is going to be, if we have two congruent corresponding hypotenuses and legs, then we'll have a congruent triangle. So if the hypotenuse and a leg of a right triangle, again, we're going to have a right triangle. If the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of another triangle, then we can say the two triangles are congruent. So let's take a look at a picture of this. We're given that triangle ABC is congruent to triangle DEF. Oh, I'm sorry, actually, we don't know they're congruent. We need to show that they're congruent. We're given that they're right triangles. So we're given two right triangles, and we need to show that they're congruent. Well, they tell us this information here. AC is congruent to DF. So AC is going to be congruent to DF. And if you remember, the side across from our right angles is always going to be the hypotenuse. So over here, I'm going to write H. In my diagram, I'm going to label that these are the congruent hypotenuses. Then down here, they tell us that BC is congruent to EF. So BC is congruent to EF. So let's put our tick marks in there. Remember, these are just the legs of the right triangle. The sides that are not a hypotenuse are the legs. So since we know we have a congruent hypotenuse, these hypotenuses are congruent, and these legs are congruent, then we can say triangle ABC is congruent to triangle DEF. So looking down at example 1, we need to show that these two triangles are congruent. So the first triangle we'll look at is right here. And the second triangle is this one right here. Thinking back to Monday, we talked about triangles that share a side. So we know that this side is congruent to itself. And because these sides are across from the right angles of the triangles, we know to call them the hypotenuse. So in our triangle, the green triangle, JGH, we have a leg congruent to a triangle in JKH, So the green leg is congruent to the orange leg, and the green hypotenuse is congruent to the orange hypotenuse. So by HL, the hypotenuse leg congruence theorem, we can say the triangles are congruent. And again, that's because we have right angles. We have right angles here and here, which means we can look at the hypotenuses. And we know that we have one pair of congruent legs.